Welcome back, mathematicians. In this video, we are going to look at the reflection transformation. There are actually two types of reflections, about the x-axis and about the y-axis. Our goal is to start with the first reflection of y is equal to negative f of x. If you're not sure which one this represents, I suggest drawing a quick picture. That negative is being applied to all the outputs, or y-coordinates, of the original or parent function, which means that if I were to have a point in quadrant number 1, the y-coordinates will change to their opposite. The x-coordinates remain the same, which means that it will be reflected into quadrant number 4, which would have the opposite y-coordinates. This then means that we have a reflection with respect to, or about, the x-axis. So this notation, again, means a reflection about the x-axis. So let's look at our example of f of x is equal to negative x squared. Let's start by graphing the parent function. The parent function without any transformations is y is equal to x squared. Making a t-table, I would get the ordered pairs of negative 2, 4, negative 1, 1, 0, 0, 1, 1, and finally 2, 4. Graphing this, we have a U-shaped curve or a parabola. I am now going to apply the transformation, and again think of it as the negative would be applied to your order of operations after you square, which is how I know I'm going to multiply all of my outputs by negative 1, or I would make them all opposite. In the table, I would just represent this as times negative 1 to each and every y coordinate. And on the graph, I would plot ordered pairs of negative 2, negative 4, negative 1, negative 1, 0, 0 will stay the same, 1, negative 1, and then 2, negative 4. And as we can see, the U-shaped curve, the parabola, has been reflected across or about the x-axis. Our second reflection would have a general form of y is equal to f of negative x, where the argument x has been replaced with negative x. So in this case, the x-coordinates will change to their opposite, or you can think of it as multiplying the x-coordinates by negative 1. If you're uncertain about which transformation this represents, go ahead and make a quick little picture where we have a point in quadrant number 1, and then plot the corresponding point with the exact opposite x-coordinate, but the y-coordinate remains the same, and that would be in quadrant number 2. Which means that this notation represents a reflection about the y-axis. So let's go to g of x is equal to the square root of negative x. I'm going to start by plotting my parent function, which is y is equal to the square root of x. Making a quick t-table, I have the order pairs of 0, 0, 1, 1, and 4, 2, which I will use to draw my graph. Now I'm going to apply that negative. So because that negative is being applied to x before you take the operation that defines the shape of the curve, in this case the square root, that's how I know I'm going to multiply my x-coordinates by negative 1, or you can think of it as changing them to their opposite. This will result in new ordered pairs of 0, 0, negative 1, 1, and finally negative 4, 2. And as you can see, the graph of the parent function has been reflected about or across the y-axis. All right, guys, good luck.